Welcome to my YouTube channel. In my top interview 150 problem series, this is the sixth problem. So here the problem says that we would be given an array and there would be mix of elements, but there would be at least one element which will have a majority. Majority element means that it occurrence in the array would be more than half of the length of the array. It means that it is occurring more than the half of the times in the array. So let's quickly jump onto the solution. We are going to use up two approaches. First approach is minimum basic approach that comes as a brute force approach. It says that we in the array we are going to use map, and we are going to maintain the frequency wise the count of occurrence of every element in a way that the frequency of every element, that how many times it is occurring in an array. And in the end we will check if at every time we are checking that the whether the element we are currently storing, whether its frequency is greater than the half of the length of the array. If that's the case, then we are simply going to return the result. So let's quickly see how this is working. You see, we have in this array we have elements as 2 2 1 1 2. Okay, so in the first iteration, for the first time it will check whether I have already written how it is its algorithm. Here we are going to maintain a frequency map, and in the frequency map it at every element it will iterate for every element, and then it will check whether for it will like frequency of a particular number, whether if it does not belong to the map, then we will add it to the map with with one frequency, and if it already belongs, then we will increment its count. And if the frequency of this array, if the frequency of this particular number in the array is greater than half of the length of the array, then we will return the number. So for zeroth, so let's quickly see how this works. 2 3 4 5 6. Think there is some problem with my pen. Just give me 1 minute. Yeah, so here you see we have initially we will have the number 2. Okay, and for 2 we will maintain the frequency 1, and then it will go and it will increment the count, it will increment the frequency, and now it will have in frequency as 2. And then then the array index will move to second array will move to the second index, and for 1 it will have frequency, initially it will have 1, and then again the frequency will move to third index, and then it will have 2 count. Then at fourth index, when I will come to the when the number will come to the 4, the count, the frequency of 1 will increase, and it will come as it will increment it to 3. Now the array index, now for this index, fifth index, it will encounter 2 and again increment its frequency, and in the end it will have the frequency 4. When it will have the frequency 4, it will reach at this point, then it will check whether the number I am currently iterating, what is its frequency. Then it will see that its frequency is coming as 4, and clearly the length of the array is 1 2 3 4 5 6 7. So 7, half of the 7 if we take, then 4 is greater than half of the length of the array, right? So in this case 2 is going to be returned as the output. But you see, here we are currently in moving through the array, so time complexity is going to be bigger often, but the space complexity, we are taking the extra space. This is the extra space we are taking right now. Okay, this is the map that we are storing. We are not using it for iteration only, we are using a frequency map. It is using an extra space. So for this we need to, the interviewer is not going to be happy with the extra space we are using, so we need to optimize this solution. Okay, so now come to the optimized solution. For optimized solution, we are going to use a very famous algorithm which is called Boyer-Murray voting algorithm problem. Voting algorithm. Okay, and this is not the extra space. This is just for the illustration. I'm going to do dry run, so that is why I have used this extra table. This is just a table for this demonstration purpose, not for the extra space. Okay. So the intuition, the voting algorithm problems is the intuition behind this problem. Let's quickly understand how this works. So suppose there are two parties in the election, and in the election team, if we have total 100, we have to take votes from 101 people, and there are two parties, then at least for one party to win, someone has the someone must have the vote of 51 count, right? So what this opposing party is doing, this opposing party is just cancelling out whatever number, whatever votes the other party has. Suppose one party has 5 votes, another party has 5 votes, so both of the parties are cancelling out each other votes. So to win, we have to outnumber the actual cancellation amount, right? Actual cancellation counts. So for winning, equal counts, so the initial 50 counts, so both of the parties are for cancelling out each other's vote, and the extra one, so in this example, when we have 100 people and we are voting and we are taking votes, so to win, initial 50 counts are just for cancelling out each other's number, each other votes, and the extra one count is going to be very crucial, so it is going to decide who is the winner. Similarly, we are going to maintain a count here, right? So there would be a count here, and this count is going to decide in the end, if its length is even one greater than, then the party is a winner. Okay, then one element is majority element. So here we are going to take a candidate, we are assuming our candidate. Just let me write here. So here we will first assume that we are having a candidate which is candidate of a winning team. Okay, so every time we are going to assume there is a candidate, and the candidate initially we will assume that we will assume that the first element. So we will assume that the first element we are encountering, it is candidate, and then we are assuming also one thing, that there is a count. Okay, so we are going to iterate the array from 0 to, we are using I to for the iteration, and we are going to iterate from 0 to n minus 1. Okay, and then this is just a way of writing, this is not a syntax, but it is just a way of writing for understanding purpose, so don't get confused here. And then every time we will iterate over a number, we will check whether the current element I am iterating is equal to the candidate. So suppose the way when I was first assumed that there is 2 which is a candidate, and then the second element, I will every time I will check for every element like this, that whether it is a candidate or not. If at all it is a candidate, then we are on the winning side. Okay, so we will just increment the current count. So there would be a count from 1 to 51, so this is that count, we are maintaining a count for the winning team. And every time if we have encountered a number and it is not equals to the candidate, it means we have to cancel the cancel. We are this is you this block, this block is for incrementing the count, and this block is for canceling the current candidate's count. So this is the block of opposite team. Okay, so this is how we are going to how we are going to cancel, we are going to do the cancellation like the voting algorithm. And if at any time the count comes as 0, if any point agar if we have seen that count is 0, now since this is the winning team and this is the opposing team, this is the candidates team that we are currently taking, that okay, we are assuming that this is the candidate and we are incrementing the count, and this is opposing team. At any point any team can win, whoever will have the greater count is going to win. So if the count is 0, we if suppose we have assumed that there is a count, in this case we will assume that there is a count. So let's come to this point later on, and then I'll explain further what we are going to do here. Initially just start. So we are first we will write the indexes quickly. We have this 0 1 2 3 4 5 6. Okay, and then we will take this element. So if we has assumed, we will assume that the nums of 0, the 2, it is a candidate, it is our candidate. And then its frequency, its count, we have assumed that initially its count is 0. Okay, so if, and now we will not start from 0, we will actually start from 1, sorry for that. So here we will start from 1, and then at first position we will check whether the nums of I, so whether my nums of I, this thing is equals to candidate. You see 2 is equals to 1, 2 is candidate, the current element also is equals to the candidate. In this case we will just increment the count. Now again the nums of I is going to increment, and it will come at the second index. At second index, you see we have 1. Now this is the opposing team. This is the winning block and this is the opposing block. So here candidates block, not winning block but the candidates block, and this is the opposing block. Then now at this point we have to come to opposing block, and then we have to decrement it. So currently this one came and it cancelled the current count. So now the count has become 1. Okay, because this came and this cancelled. Since it is not 0, we don't have to do anything. And now after cancelling its current count, it will go and increment again, current index. Now we have reached to the third index. At third index as well we have one row. Sorry, so let me erase this. Yes, so you see we at third index as well we have 1. Now what will happen? It will again come and it will, sorry, it will come and it will again, whatever count we had, it will cancel. So 2 was initially, we were supposing that it is our candidate and it is on the winning side, but now 1 came up and it cancelled all the count. Now the count is 0. What will happen if the count is 0? At this point, when a opposing team came up and then it cancelled the current elements count, now we will assume that the current element we are iterating is now this element is our candidate. So if any element comes up later on and then cancels all the candidate elements count, then we will assume after it gets the count gets 0 that the current element which is coming at multiple times and cancelled all the counts, this is the current candidate now, and then we will set it counts to 1. Okay, so 1 currently at third point 1 came up for till the second point this one was 1 made it 0. At fourth index when it came up, it proved that okay, I can also be the candidate. The earlier candidate, it came only 2 times, but see I have come up at least 3 times. Now I am eligible for becoming a new candidate. At this point, at third point only it will become a candidate because it came up 2 times. See, it initially 2 was came up 2 times, 1 came up 2 times. So even after coming up 2 times and cancelling this count, it has become now a candidate and it will have a count of 1. And when it will come now, I will increment and it will come and it will reach to the fourth index. It will say that see I have it will increment its count. So since this is the current candidate, the candidate is 1, it will come up at fourth index and it will increment its count and its count will become 2. Now see, this is looking like a election scheme. Now see what happens. Now we are at fourth index and the count of one is 2 after cancelling its point. Okay, now we have to now after incrementing its count as 2, we will again increment. Now I will increment and come at fifth index. At fifth index we have encountered 2 which is not equals to candidate. At this point we have candidate as 1, not 2. 2 will come and see okay, I cannot go to this block, I will come to this block, I will come to this block, and then I will decrement the current elements count, current candidates count. So 2 the count of 1 will become 1. It has cancelled its occurrence. 2 cancelled its occurrence. And then after cancelling it's in the, since the count is yet 1 not 0, so it will not come to this block. Again it will go, the index I will increment, I index will increment and it will come at this point. At this point also it cannot go to this block because currently 1 is the candidate and 2 is not the candidate, because count of 1 is still 1. It will come to else block, it will decrement the current count of the candidate and it will make it 0. Only when the count of the current candidate becomes 0, now 2 will say I am now eligible to become a new candidate. So when one's count gets 0, 2 will become the candidate. 2 here is candidate now and its count will become 1, and now we see that we have reached till end of the array. So we will simply return this as a current candidate. So this is the current candidate. This is going to be returned as majority element. I hope you have understood. There is second example as well. Please try on your own. Let's quickly jump to the solution and see how we are going to write the solution. This is going to be the same only. Let's quickly jump to the solution and write the solution. We will currently let that candidate is nums of 0, and then we will let our I initially as 0, and sorry 1, because we have already assumed that nums of 0 is a candidate, and then our I will move till the length of the I has to be less than length of the nums, okay, minus 1. Please let me know if I am moving fast. I'll go slow a bit so that everybody understands, okay. And initially this is the candidates block. If current nums of I is also a candidate, that current element I am iterating, then I am simply going to increment the count as I have explained earlier, okay. And then this is the candidates count, where candidates will say, see, I have occurred again, and please increment my count. And this is the opposing party count, which has came up to cancel the current candidates count, okay. Now we see we have this for loop ended else here, then for loop ends here. After the for loop ends, we will simply return the current candidate. You can also write this like for better understanding. I hope you have understood the current algorithm, this solution. Now just simply return it and then check whether this is working or not. Okay, so there is one time and next I have must have messed up with some opening or closing bracket. Let's check. Okay, so let's see, this is ending here, this is proper, this is proper. Oh, so we have this in here, and then we have to fix this as well. Let's try to run this again. Okay, so this is accepted. Let's submit it. Okay, this is submitted. Now you see this is how we are running this. The time complexity is going to be big of n, and then this I hope you have must have understood. Thank you for learning. Thank you for coming to my channel.